Hi, hello. So, in this today class, we are going to start with the module 3. Jikle. So, first module we completed the introduction about the architecture and all 8051 basic. Second module we studied about instruction set of the 8051, that is with respect to complete assembly programming instruction set. So, after completion of the module 2, in module 3, that is related to the stack. So, in module 3, it is going to cover about the stack and what mean by the subroutines and some of the few instructions along with the IO port programming. IO port program is nothing but input and output port programming. How to use the port pins, individual port pins as the input and output, how to make the programming. So that concept we are going to study about in the third module. So in this first one we are going to start with the stack here. So stack in the 8051, first we need to start this one. But before going to start this one, already in the first module we covered, that is the internal memory structure of the RAM, that is a 128 byte, how they are divided, that diagram I given in the first module. So that one, the first we need to discuss that one. So here this is the internal RAM allocation in the 8051. This diagram is similar to that first module like given internal structure, internal RAM of the 8051. So it is starting from, this is the 00 to the last one is the 7F. So this range we are going to call it as the 128 bytes of RAM, because 8051 it supports 128 byte. So that means 128 byte. So 128, that is the decimal number. So that means I started with the 00. So that means 00. So again, so last one is the 127. If I take 128 byte, if I start with 00 means last range should be the 127. So that means decimal 127. If you convert it to hexa, it will come the 7F. So for that we are going to show this hexadecimal number 00 to 7F. This is a range in the hexa. In decimal it will come 0 to 127. That means 128 bytes of internal RAM. So already know that one. So this entire internal RAM 128 we are going to divide into three sections. One is the register bank. So this is the register bank 0, 1, 2, 3. This is complete, these four are registers bank. So next one is the bit addressable RAM, second part. Third RAM is general purpose RAM. So sometimes they are going to call it as a scratch pad RAM also. Both are same, scratch pad RAM or general purpose RAM also. So that means what you need to understand, the entire thing they are going to divide with the three sections. Is it clear? So here stack is nothing but it is also part of the RAM itself. So part of the RAM itself, in the sense we are going to say like whenever you are going to power up or switch on the microcontroller, is it clear? So stack that stack pointer, stack register, it will hold the address starting with 07 only. So that means when you are going to switch on the microcontroller, stack pointer always start, or default case it will hold 07, that is the memory location, byte memory location will be 07. So that means once it started 07, always start 07. So next one is first memory location itself 08 onwards it is going to store it in the stack. So that means first it will hold the 07. 07 is nothing but this is it used for some other purpose starting. Next address is the 08. From the 08 up to the 1F. So that means already you know that register bank means, if we say the register bank 0 means here the internally 8 registers will be there. So that is R0, R1, R2, R3 up to R7. Register bank 1 means again R0, R1, R2 up to R7. So that means what you need to understand, from the 00 to 07 means this is the range is 8. So again this is 8. So that means this is the 8, 8, 8. It is this like it's splitted. So for means RAM stack is going to start with 08 up to the 1F means this is 8, 16, this is 24. So that means 24 bytes range we are going to call, this is the region we are going to call it as the stack only. So from 08 up to the 1F we are going to call this is the stack. That means how to define the stack here. Stack is also the section or part of the RAM. So that is also used for to storage of the information as the temporarily only. Because RAM is mainly we are going for the temporary storage memory, because ROM is a permanent memory. So that means RAM itself is the temporary storage memory, means obviously I can say the stack also it perform in the storage for temporary only. So if anybody asks what is meant by stack, means you need to tell stack is also the section of the RAM used by the CPUs to store information temporarily. This is the definition of the stack. Exactly. If anybody asks what is the range of the stack, means you need to tell that is 08 to up to the 1F. The total means we can say this is the 24 bytes. Means this is the 8, next 8 16, next 8 means 24 bytes of the stack RAM. Is it clear? So that means, so this is a diagram for explanation of the stack. How we are going to say this is a part of the RAM means by seeing this diagram you come to know very easily. Is it clear? So here already I said this is the definition of the stack, and here information means it may be the data or it may be the address also. So that means stack pointer, it holds data as well as the address of the any of the registers also. Is it clear? So next part is how to stack assess, how to stacks are assessed in the 8051. Is it clear? So already I said stack is also the part of the RAM is nothing but it going to consisting of different memory locations. But if I want to access the particular memory location means I needed the pointer register. Yes or no? How to access that stack memory means here I am going to use the one of the register, that one we are going to call it as the stack pointer. So the stack pointer, it helps to point out to the particular memory location for the stack concept. Is it clear? And this stack pointer also, it is the 8-bit register. 8-bit register is the sense we can say this is, if you make a 2 power of 8 means it will come the 256. So that means if you start with the 00, obviously it is the 255. Is it clear? If you convert 255 to hexa, it will come, this is the 00 to double F. So 00 to double F. So that means what you say here, 8-bit register, that means that range will be, this is the 00 to double F, maximum double F. So that means if anybody asks what is the range of the stack pointer means that is the 00 to double F. So if anybody asks, sir, after the double F what will happen? Again it will rolls down. Rolls down is nothing but once you cross the double F, again it should start from 00 itself. That means we are going to call it as this is a rolls over from FF to the 00. So again here already I said when you are going to power up the 8051, stack pointer is going to contain the values of 07 only. So that means already I explained in this diagram. So when you are going to switch on the microcontroller, the stack pointer holds the address location that is the 07 only. So that means after the 07 what is there? 08 is there. That means 08 is nothing but first memory allocation of the stack pointer, it will be the 08 only, not 07. 07 just like starting initial, but going to access data or memory location is going to perform by the first memory location, that is the 08 only. So for that we are going to say this is RAM location 08 is the first location used for the stack by the 8051. Clear? So next one, already you know studied in the second module also, stack we are going to access by using the two instruction set. So one is the push, one more is the pop instruction. So already you know that push and pop is nothing but I am pushing the something register, I mean the content from the register onto the stack. Stack is nothing but I can say this is the part of the RAM, means I can show this is the RAM. Pop is nothing but it is the exact reverse operation of the push, that is nothing but retrieve the content from the stack onto the CPU register. Is it clear? This is just diagram for to say about what is the push and pop. Is it clear? But in depth we need to study about push and pop, how it is going to work. Is it clear? So for here we need to start with the first push. Push is nothing but already we know that here the CPU registers are there. So I can say this is your the source side. So again it will transport to the onto the RAM or the stack. So again stack from the some other register. That means I can say this is your source. Here this side it will act as your destination part. This is your the intermediate somewhat allocator. That means it is a temporary. Yes or no? This is it will act as a temporary here. So only intention is it will make the speed up the processing. So here in pushing is what will happen here. Push is nothing but already we know that here we are using the sum of the set of the registers here. So whatever the content of register I will push onto the stack. So for example what will happen if I use the some registers here or not. If I use the some register or not, it will push to here. So that means content again it will come in the RAM only. So again next one more R1 is there. Again if I push the content of R1 means again it will store the in second memory location. That means when you are going to perform the pushing operation, it is going to increase the content of the stack towards the top side. So that means whatever the length of the stack is there, it is going to get increased one by one. One by one is nothing but we can say this is performing the increment operation. So that's why we are going to tell push is nothing but it will perform the increment operation. Increment is nothing but plus 1, it will add it. So if anybody asks what is the status of the stack is nothing but it is going to get the increase toward the top side. So similarly pop is nothing but what will happen is the exact reverse of the push operation. So exact reverse of the push operation means what will happen? So here whatever the top content is there, exactly, first it will retrieve, it will remove from the stack here, it will store the some other CPU register. So again what will happen if I perform here pop one more operation here, at the time what will happen is it will take the second content here, second memory location content, again it will remove here. So that means when you are performing the pop operation, it will remove the content from the stack to the some other CPU register. That means whatever the length of the stack here, it is going to get decrement. So for that decrement by 1. So for that pop is nothing but it perform decrement by 1 operation. So that means length of the stack it is going to get reduced here. When you are going to compare the push, it is going to increase the length of the stack. So this is the reverse between the difference between the push and the pop here. So second thing you need to understand here, to push the registers onto the stack, we must use the RAM addresses only. So that means when you are going to write the instruction push and pop, is it clear? We need to use only the RAM addresses for the respective register set only. So that means we can say we need to use only the direct addressing mode only. Direct addressing mode in the sense we can't use the registers, only the address of the memory address of the registers or memory location we are going to write. So for example, if I write push 1 here, if I write directly push space 1 is nothing but it is going to tell like that, pushes the register content R1 onto the stack. So 1 is indicate this is the memory location for the R1 register. Is it clear? So that means here if instead of 1 here, if I write push space R1, this is the invalid instruction. This is not a correct instruction because here we can't write the register directly here. We need to write the address of the register. So what is the address of this R1 register? That is the, if we write 1, this is the invalid. If you want to perform the pushing operation for the R3 register, that is nothing but that is the equivalent of memory address, that is the 3. So that means you need to write push space 3. That is going to tell about push the contents of the R3 only. So that means we need to use only the direct memory address of the respective registers only. We can't write the register directly. So this one you need to remember very careful. So this is pushing also. In pop operation that is also same. If you write pop space 1, that is valid. If you write a pop space R1, that is the invalid. We need to write only the direct memory location for the respective registers only. So here I can say give the one example here. In exam also they will give this type of examples. So let me to start. Show the stack and stack pointer for the following. Assume the default stack area and the register 0 is selected. So that means he is saying like that he given the one program. He is asking about show the stack and stack pointer. So stack is nothing but you need to show the what is the content of the stack, and is asked stack pointer means when you are going to show the content of the stack here, that respective stack pointer value what it will be there. So he is asking about in this program. So what he given the program here, move space R6 comma hash is 25h. Again R1 is that means 25 loaded to R6, 12 also loaded to R1, 0 F3 loaded to R4. So one more you need to understand, when you are going to write this is your the LSB bit. So this is your MSB bit. Is it clear? When you are writing the in MSB bit like the character something like A to F, that means A, B, C, D, E, F. When you are going to write in MSB bit A to F any of the character, at the time you need to write zeros. So that means this is the way of the representation for this type of the characters. When you are writing the 25 decimal value, something like hexadecimal value 25, 12, these are digits, no need to add the zeros here. But when you are writing MSB bit as the A, B, C, D, F, any one of the character in MSB, at the time you need to attach the zeros. Then only it will accept as the F3. If you remove this one, you can also check in Keel software also. If you remove the 0, if you write only the F3, it shows that something error here. So that means we need to attach here 0. So second time what is written here, push space 6, push 1 and the push 4. So already I said if you want to perform the pushing operation for R6, if you write R6 that is invalid. For that he written push 6 is nothing but this is the direct memory location for the address location for the R6. If you write push 1 is nothing but this is the address location for 1 that is R1 and push R4. 4 is nothing but this is the direct memory address for the R4. Is it clear? So after this what will happen? Already I said when you are going to switch on your microcontroller, is it clear? Value of the stack it always hold 07. So that means what will happen here? Always 07 means start stack pointer it will hold always 07. So what is the next byte memory address? That is will be the 08, 09. So after the 9 means 10. 10 means 0A, 0B means 11. Is it clear? So that means this is the byte address will be there because 07 is the starting. So what is the next? From the 08 onwards it is going to store your the data. So first what will happen when you perform in the push 6, that means push the content of the R6. This when it going to execute here, what it will change the content here. So push 6 is nothing but pushing the content of R6 means R6 means what is the content? 25 onto the stack. So that means what will happen? This value 25 it is going to store in your stack. In the previous case it is all are 00s. When this instruction is going to execute, so push 6 is nothing but 25 is going to store itself in the stack. Stack means what will happen? Already I said default case 07. So next byte address is 08. So from this address onward is going to store the data. So for after push 6 means what will happen? 08 it is going to hold the value of 25. Why it is only 25 here? I am performing push 6 is nothing but 6 means R6. What is the content? 25. So that means you're going to store 25. So for example, I can say this one. This is your RAM. So this is your register set. So here, so these are your registers, and this is the push operation. So from here, this is your the pop. So that means push 6 is nothing but 25 is here in register. This one I am going to store in the RAM. So 25 here. So what is this address here? It will always starting means 08. Clear? So next when you performing the push space 1 here, at the time what will happen? Push space 1 means R1. What is the R1 content? 12. So again it is going to store in the RAM location, that is 9. So why 9 means 08 already occupied by 25. So next when you performing the next push operation, that is after push 1. So this 12 it is going to store in the second value. What is happening here? When you are performing the pushing, it is going to increase the content toward the top side. That one you need to observe. So last one, push space 4 means what will happen? After the push 4 here. So push 4 means R4. What is the content? 0F3. So this 0F3 it is going to store here at the address location 0A. Is it clear? So that means this is after pushing the 6. So one content it will store. After push 1 means again it is going to store in the second memory location. So that means toward the top side it will increase. After push more it will increase here. So these addresses are, this is every time it is fixed. So here whatever is going to 08 from onwards it is going to get continuous. So here also it will get continuation. So in your exam they will give this type of the program. They will ask show me the content of the stack and stack pointer. Is it clear? So whatever you are going to write here, this content, this is about the stack, status of the stack here. Is it clear? But what is the status of the stack pointer? Is it clear? Stack pointer means this is your the pointer register to make pointer to the particular memory location for the stack. So here also already I said stack pointer always it hold the address, the address of the top of the content. So what is the, how many contents are there here? Only one content is there. So one content itself, this is the top of the content in the entire stack. So at the time stack pointer it holds this address 08. So when you are coming for this second push here what will happen? Two elements are there. One data is here, one more data is here. So stack pointer is nothing but always it holds the top memory address of the top content. So which one is the top content here? 12. This is the top content. So what is the address here? 09. So stack pointer it will show the 09. So in this case what will happen? Here the three are there. One data, second, third data is there. So which one is the top content here? This is F3. What is the address here? F3 content, that is the 0A. So what is the stack pointer address? It should be the 0A. Is it clear? So these are the addresses, these are the data. Is it clear? So that means they asked in a question itself, this is the stack content. Stack pointer is nothing but you need to write the address of the individual steps. Is it clear? This is very, very important, and try to make the practice.